In this video, we'll discuss a creational design pattern that is extremely popular and widely used. This is the Singleton pattern, where we ensure that there is exactly one instance of an object. The Singleton pattern is useful when exactly one object is needed to coordinate actions across the system. When you apply the Singleton pattern in your code, you're essentially setting up a class or function of which exactly one instance can exist. You can have just one function object or one instance of a class. When you implement the Singleton pattern, you have to actively ensure that clients are prevented from creating multiple instances of this class. You need to ensure that the class is instantiated exactly once, and you need to provide a global point of access to that single instance. So, whenever any part of your application code needs access to an instance of the singleton class, we need to ensure that we return a reference to the only object or the only instance that is in existence. The singleton pattern is typically used whether in JavaScript or other programming languages to control access to resources so that all access to that resource is gated through the same singleton object. There are some other characteristics which are typical for the singleton pattern. You lazily instantiate the singleton object only when absolutely needed. The singleton object might be heavy duty and might hog a lot of resources in your system. So you'll only create the object when there is some client code which references and needs to use that object. If the object is never referenced, it will not be created. That is lazy instantiation. When you use the singleton pattern in JavaScript, singletons serve as a shared resource namespace. So all of the shared resources are placed within this singleton object, and then you isolate the implementation of this object from the global namespace. The singleton is a shared global object, and the methods that you expose on the singleton are a single point of access for the rest of your code to the underlying resources that the singleton controls. So here are some typical characteristics of the singleton object that we create using the singleton pattern. Now, the singleton is a global object. There is no clear owner of the object. It's not that the singleton is owned by a certain component and then used by other components. It should be equally accessible to all components with no owner. It's quite common for the singleton object to be an expensive resource to instantiate. It might take up a lot of memory. It might make expensive external connections which take time to set up. So it's good practice to lazily instantiate the singleton. It helps performance. Lazy instantiation means that unless your application code references the singleton object, it will not be instantiated, and object will not be created. Once you've set up your implementation to ensure that only a single instance of the object can be created, you need to provide a single global way to access the object. Any client code which makes a request to get access to the singleton will use the same global point of access. Here is a high level visualization of how the singleton pattern works and how you might choose to implement it. There is a global point of access, which is either a component or a module or some kind of system which gives you access to the singleton. Behind this global point of access is a single instance of the singleton which is created on demand. The singleton object is typically not created till a client requests for it. Once a client makes a request for the singleton object, this module or component will create an instance behind the scenes and return a reference to this instance to the client code. Now, you might have multiple clients within your program or system, all of which require access to this singleton instance. When another second client makes this request, this singleton component or module ensures that a reference to the same instance, the single instance that has been created, is returned to the second client as well, to the third client, to the fourth client, and so on. The singleton pattern is very popular and widely used, especially for expensive resources for which you want just one instance. Let's say a connection to an external database. But before you apply the singleton pattern, there are certain things you may need to keep in mind. The use of singletons may indicate that your modules are tightly coupled. The use of the singleton pattern may also make your code harder to test because your code might contain hidden dependencies for that single global object. In this clip, we'll move on to the discussion and implementation of another very commonly used creational design pattern, that of a singleton. All of the code that we'll write for the singleton pattern is under this directory called singleton pattern. We have the singleton pattern.html file and the corresponding JS file where we'll write our code. The idea behind the singleton design pattern is exactly what its name implies. The singleton pattern, when implemented, allows the creation of only a single instance of a class, and all code that you use references this same instance. So you have a class or a function object in our case, but there can be just a single instance of that function object referenced by all of our code. The singleton instance usually serves as a gateway to access common utilities. The singleton instance is usually lazily instantiated, that is, it is created only when actually accessed. It's not created upfront. Once again, the HTML file for this demo is relatively straightforward. We only have the h2 header, the singleton pattern. All of the interesting stuff is in the singleton pattern.js file. In this JS file, I'm going to write some code to set up a logger class. I want this logger class to be instantiated as a singleton. That is, I want the same instance of logger to be used throughout my code. Now you'll see in the code that I write here that I'm going to build up this singleton pattern iteratively. This will allow you to follow and internalize all of the little details that you have to take into account in order to ensure that this class is indeed a singleton. Here is our class logger. Within the constructor of this logger, I'm going to generate a random number using math.random. Generating this random number within the constructor is a quick and dirty way that I have chosen to check whether just one instance of this class exists or there are multiple instances. If we end up creating multiple instances of this logger class, each instance will have a different random number. There's, of course, a very small possibility that two random numbers generated are exactly the same, but since that's very, very small, we can just ignore that. So, this random number is just a helper to allow us to see how many instances of this class have been instantiated. The logger class has a single log function which takes as an input argument the message and prints out a logging message to the console log. We'll simply invoke console.log and print out the message that was passed in. In addition, we'll also print out the logger ID, the random number that was generated for this instance. I'm now going to use an immediately invoked function in order to instantiate and return an instance of this logger class. Now, I've called this not really singleton logger because it's not really implementing a singleton. It is an immediately invoked function though. The function definition begins on line 12 with the opening of the first parenthesis and it ends on line 15 where the parenthesis is closed. And then we immediately have an open close parenthesis which invokes this function. Now, what exactly do we have within this function? I have set up an variable called instance which holds an instance of the logger. This instance variable is only available within the scope of this function and is not in the global namespace of JavaScript. Now, let's go ahead and return an object which represents our not really singleton logger. The object that we return from this immediately invoked function is very straightforward. It contains a single function called getInstance. GetInstance simply creates a new logger instance and assigns it to the instance variable and returns that logger. This getInstance function has access to the instance variable because the instance variable is a part of its closure. Now, this is what we'll use to get access to a logger object. It's pretty clear from the code here that the logger is not really a singleton. Each time we call getInstance, we are instantiating a new logger object. That's totally fine for now. Remember, I had mentioned earlier that we are going to build up our singleton iteratively. Let's first instantiate our first logger called logger1. We'll invoke the getInstance function on the not really singleton logger object. That gives us logger1, and I'll now use logger1 to log out to screen. This is not really a singleton. We already knew this. How do we prove that this is not a singleton? Well, let's see. Switch over to your Chrome browser window and click through to the singleton pattern.html file. When the code executes, the two messages that we had logged to the console are printed out within our Chrome developer tools. You can see that the logger ID here remains the same because we are using the same logger instance. I'm now going to head back to my code editor and call not really singleton logger.getInstance once again and assign that object to logger2. This is a different logger that I have instantiated. I'll now call logger2.log, and the message that I have here is note the random number associated with this logger. I print out another log message using the same logger2 instance, and this message says a new instance has been created. We really need to fix this. Now, the fact that we have logger1 and logger2, you'll see that they have different random numbers associated with them. You can see that the logger ID for the first logger starts with 0.47 and the logger ID for the second logger starts with 0.76. This conclusively proves that logger1 and logger2 are different logger instances. And in fact, we knew that when we had written the code for the getInstance function. If you remember the code for the getInstance function, each time getInstance is called, we instantiate a new logger object and assign it to the instance variable and return this new logger object. So this in no way is a singleton. So we really need to fix this code to see if we can instantiate a singleton. So let's go back here and delete all of the code that we've written so far for the not so singleton logger. So what we are left with in the JS file here for the singleton pattern is simply the logger class that we had defined. I'm going to make another attempt at setting up this logger class as a singleton object. Once again, I'll use an immediately invoked function, and the object that I return from that function, I'm going to store in the variable still not really singleton logger. This variable name ought to give you a clue that this new improved singleton logger will not really be a singleton. Let's first check it out. I have a var instance here within my immediately invoked function, and this is the object that I return. It has a getInstance function, and the code within this getInstance function is what I have fixed in order to ensure that I create just one instance of the logger. Observe that before I create a new logger instance, I check to see whether the instance already has a reference to a logger object. If yes, I go directly to the return statement and return the same logger instance that has been previously created. If we haven't created a logger instance before, we get into the body of the if block and we create a new logger and assign it to the instance variable. Now it seems like this statement ought to do the trick. If there is an instance, we'll return that one. Otherwise, we'll create a new logger instance. Let's see how this works. I'm going to use still not really singleton logger.getInstance to create a new logger instance that I assign to logger1. I'll then call logger1.log and log out a message. The message says this is not really a singleton. Well, okay, but why? How do we know this? How do we know that this is not a singleton? Let's head over to the Chrome browser and clear the console of our previous messages and hit refresh. Once you hit refresh, you'll see two messages in the console log, and you can see that the logger ID is exactly the same for both of these messages. The logger ID starts with 0.045. Both of our messages have been logged using logger1, so it makes sense that it's the same logger ID. Let's switch back and call still not really a singleton logger.getInstance and assign that instance to logger2. I'll now use logger2 to log two more messages to the console. The first one says, note the random number associated with this logger. And the second one says, well, the random number is the same. It seems like we've successfully implemented a singleton. Let's switch over to Chrome and hit refresh and take a look at the console messages. You can see that all of the logger IDs are exactly the same. They all start with 0.425. If you purely look at these log messages, it seems like we have successfully implemented the singleton pattern. There is just one instance of the logger that is returned each time we call getInstance. Well, let's see the flaw in our thinking. What if I were to instantiate a logger using this technique? I simply call new on the logger class and instantiate and assign a new logger to logger 3. Here is the message that I display to screen using logger 3. It's not a singleton if we can directly instantiate the logger. Let's hit refresh on the Chrome browser and you can see that logger 3 has a different ID. All other loggers which we got using get instance have ID starting with 0.71. Logger 3 has an ID which starts with 0.22. The fact that we can directly instantiate a new logger using the logger class means that we haven't successfully implemented a singleton. Back to the drawing board. We really need to get our singleton right this time around. I'm going to go ahead and select and delete all of the code that we've written so far. Not really a singleton, a logger. I'm going to select all of this and hit delete. And here is our logger class. I'm going to select this and hit cut as well. I'm going to redefine my logger in a slightly different way using immediately invoked functions and closures. In order to ensure that the logger class is indeed a singleton, that is, exactly one instance exists, you need to ensure that the logger class cannot be directly instantiated by users of your code. And for this, I'll set up an immediately invoked function. The immediately invoked function in JavaScript allows me to declare classes and variables that are hidden from the global scope, that are not accessible to anyone other than methods within this function. So how do we achieve this? The return value of my immediately invoked function I assign to the variable called singleton logger. I start my function definition on line 1 with the opening parenthesis and my function definition ends on line 15 with the closing parenthesis. Immediately after the function definition is complete on line 15, I have the open close parenthesis indicating that I invoke the function that I've just defined. Now let's take a look at this function body. I have the variable instance which will hold an instance of my logger object. I have also placed my class definition for the logger within the function. Placing the class within this function means that code outside of this function cannot instantiate the logger directly. So here is the logger class with the same code that we've seen before. We have the constructor where we generate and assign a random number to this dot random number, and we have the log function which prints out the logger ID and the message that is passed in. We are now finally set up correctly for our singleton pattern. I return an object from this immediately invoked function which has a single function called getInstance. Within getInstance, I check to see whether an instance has already been created. If yes, I return the previously created instance. If no logger instance exists, I instantiate a new logger, and this is the logger instance that is returned. This new logger will be instantiated only if no logger has been created previously. And it's also important that this new logger code can be invoked only within the outer function. This is because I have defined the logger class so that it's a part of the closure for this get instance inner function. Let's take our singleton logger for a test run to confirm that this works. I call singleton logger.getInstance and assign the logger object to logger1, and I use logger1 to log a few messages onto the console. Finally, we have a singleton. How do we confirm that this is indeed a singleton? Well, let's switch over to Chrome and hit refresh, and you'll see that the logger ID here is the same. The logger ID starts with 0.64. Well, I've only instantiated one logger so far. I've only invoked get instance once. I'll switch back to our code editor and instantiate another logger, singleton logger.getInstance, which I assign to logger2, and then I use logger2 to log a message onto the console. Now, this message makes things very clear. The only way for me to get access to a logger instance is to use this get instance function on the singleton logger, and I cannot instantiate the logger directly because it's not available on the global scope. We've plugged in all of the loopholes here and finally managed to create a singleton logger. Hit refresh on Chrome and we can see that the logger ID is the same in all cases. We've successfully created a singleton that can be used throughout our program. It took us a few iterations of code to get there, but we have the logger set up correctly as a singleton in JavaScript. The next creational design pattern that we'll discuss in this video is the prototype pattern. The prototype pattern is what you'll use when the type of objects you want to create is determined by a prototypical instance, which is then cloned to produce new objects. The main idea is that you have an existing object that matches certain specifications and you want to create other objects of the same type. So you use the existing objects as a prototype. You'll then use this prototype object as a template to create other object instances which are similar and have the same characteristics as the prototype. So, what is the template specification that a prototype might provide in JavaScript? So, you have an existing object with a certain number of properties and values for those properties. You might have also defined methods on an object. The object's properties and functionality serve as a prototype for other objects that you create. Thus, in essence, you're using the prototype object that is in existence as a blueprint for what other objects should look like. The prototype can serve as an interface for common methods that you want all your cloned objects to share. An important reason that you might want to use the prototype pattern for object creation is to avoid the inherent cost of creating a new object in the standard way. For example, using the new keyword. If creating a new object is prohibitively expensive for a given application, the prototype pattern is a great solution. Now, in other programming languages such as Java, the prototype pattern may not be an important creational design pattern, but in JavaScript, it takes on special importance because of how inheritance is implemented in JavaScript. JavaScript inherently uses prototypical inheritance. Everything in a function object's prototype property is inherited by all objects created using that function. When used in JavaScript, the prototype pattern for object creation can offer a significant performance boost, especially when you're creating a large number of objects. This is because of the use of native JavaScript functionality, that is, using the prototype object on functions to have multiple objects share common characteristics or methods. Let's take a look at a visual overview of how you might implement the prototype pattern in any programming language, including JavaScript. An object serves as a prototype, and you have some kind of ability to clone this object. Maybe the object itself exposes a clone method. In JavaScript, the additional clone method for the prototype is not really needed because there are other ways to create objects from prototypes. The client code will reference the prototype object and use it to create clones of this prototype. All of these clones will share the methods and properties available on the original prototype object. The prototype object essentially offers a way to create copies of itself. The prototype pattern is a great way to create objects with certain built-in characteristics. In this video, we'll explore a few techniques that we can use to implement the prototype design pattern in JavaScript. All of our code we'll be writing in the prototype pattern.js file under the folder prototype pattern. So what is the prototype pattern? This design pattern allows us to create object clones, that is, create a new object using a previously created object as a template for that new object. Now, if this seems like something that is very obvious and something that we have done before in JavaScript, well, you're absolutely correct. The fact that every object in JavaScript has a prototype property and we can assign values to this prototype when we create an object, well, makes JavaScript perfect to implement the prototype pattern. The HTML code for this demo is straightforward. We have the H2 header prototype pattern. All of the interesting stuff will be in the prototype pattern.js file, and that's where we'll head now. The first thing that I'm going to set up here is an object that will serve as a prototype, which we'll use to create new objects. This prototype object is called school, and I've specified a name and number of students for the school. The name is Orchid School of Learning, and num students is 1200. In addition to the name and num students property, we'll also set up some functions on this prototype object. Enroll student is a function which takes in a student name and enrolls that student in this school. We'll just print out a console log message enrolling student name in this dot name. This dot name is the name of the school. I'll define another function here on this school prototype object. This function is called conduct class. This is basically what will be invoked when the school conducts a class or some course. It takes in an input argument, that is the class name, and we'll simply print out a console log message conducting class name in this dot name, where this dot name is the name of the school. We'll now use prototypical inheritance in order to create new objects from this school object that we have just defined. Prototypical inheritance is basically the inheritance that JavaScript follows. We'll create new objects using this school object here, and this school object's functions will become a part of the new object's prototype. This is the prototype design pattern, which is an inherent part of JavaScript. So I'm going to go ahead and create a new object called SomeSchool using the object.create function that we've encountered earlier. The input argument that we pass into object.create is the school object that we have just defined. And the properties and functions of the school object become a part of the new SomeSchool object's prototype. I'm now going to use console.log statements to explore both of these objects. The original school object, which we used as a prototype to create another object assigned to the SomeSchool variable. Save all of the files here and let's head over to the Chrome browser and click through to the prototype pattern.html file. Open up Chrome Developer Tools and you can see the two objects are present in the console logs. I'm going to expand the original school object that we used as a prototype. You can see that it has two functions, conduct class and enroll student, and two properties, name and num students. This is the original object that we had set up to serve as a prototype. If you expand the proto property of this particular object, you'll see that it inherits from the object base class in JavaScript. All of the functions here in the original school object's proto property are functions in the object base class of JavaScript. Let's now go on and take a look at the object corresponding to SomeSchool. This is the object that we had created using the prototype pattern, and the prototype was the original school object that we just explored. The SomeSchool object does not have any properties or functions of its own, but if you expand the proto property, you'll see the functions available in the original school object that we used as a prototype to create this SomeSchool object. Conduct class and enroll student are the methods that are available. The name property is set to Orchid School of Learning and num students to 1200. These functions and properties are available in the SomeSchool object that was created using the prototype pattern. And we can confirm this by invoking enroll student and conduct class on the SomeSchool object. Once you've made these code changes, save these files and let's switch back to Chrome and hit refresh. And you can take a look at the console log messages which are displayed because we enrolled a new student and conducted a class. I'll now head back to the code editor and update the name and num students property so that the school name is now Cherry Blossom School and num students is equal to 1500. Let's log out this new updated SomeSchool object and take a look at this object within our browser window. You can see from the console messages on screen that the SomeSchool object that we created using the prototype pattern now has updated values for school name. It's now Cherry Blossom School and number of students, which is 1500. You can take a look at the proto property of this object to confirm to yourself that it indeed has the functions in the original school object, conduct class and enroll students. Observe the value of the name of the school and the num students property that it got from the original prototype. The original prototype had Orchid School of Learning and num students was 1200, but we've updated the value of those properties in this SomeSchool object. The name of the school has been updated to Cherry Blossom School and num students to 1500 rather than 1200. If we now invoke these functions, enroll student and conduct class on the SomeSchool object, the functions will reference the updated properties on those objects. Let's hit refresh here And you can see that Bob has been enrolled in Cherry Blossom School and the math class is conducted in the Cherry Blossom School. Now that we've understood how we can implement the prototype design pattern in JavaScript to create objects that are clones of existing objects, let's modify our example a little bit to create prototypes the right way. So I'm going to select all of the code that exists in this file and hit delete. When you use the prototype design pattern in JavaScript, that is, clone objects using prototypical inheritance, the standard practice is to just have all of the methods defined in the prototype and not the properties of the object. For example, in this school prototype here, instead of having the name and the number of students enrolled in the school, we'll only have the functions. The first function that we'll define in this prototype object is the enroll student function, which enrolls the student defined by student name into the current school. We'll have a simple console log message as we did before. The second function that I define on the school prototype is the conduct class function. This is the function that will be invoked to conduct a class or a course in this school. We take in the class name and print out a console log message. Now, functions should be defined on the prototype. The properties should be a part of the object creation, and that's exactly what we'll do here. I'll use the object.create function that we've seen earlier, and I'll create a new object, and the template of the prototype that this object.create function will use to create the new object is the school prototype that we just set up. The school prototype only contains the methods that the new object will have. It does not contain any properties, and we'll specify the properties separately during object creation. The second input argument to object.create is an object which contains the properties that we want the new object to have. We have the name property with the value Cherry Blossom School. We want this property to be writable, enumerable, and configurable. These are the default values for any property on a JavaScript object. We also want the newly created Cherry Blossom School object to have a num students property. The value for this property is 1500 and this property is writable, enumerable, and configurable. All of these are set to true. The function object.create with the parameters that we've passed in will create a new object which gets the functions from the school prototype and the properties from the object that we've passed in for name and num students. Let's print out to the console log the Cherry Blossom School object, switch over to Chrome and hit refresh. And here in the console messages is the Cherry Blossom School object, the one that we just created using object.create. Name is Cherry Blossom School, num students is 1500, and if you expand the proto property, you'll see the functions that it inherited from the school prototype, conduct class and enroll student. When you're using the prototype design pattern in JavaScript, a good practice is to have the functions be part of an object that you use for prototypal inheritance and the properties be part of the object creation process. Let's head back to the code here and enroll Elise in Cherry Blossom School and conduct statistics as a course. If you switch back to Chrome and hit refresh, you can see that these function invocations have been successful. You can see that Elise has been enrolled in the Cherry Blossom School and statistics is conducted in the same school. I'm going to go back to the code here and use the same object.create function to create a new object using the school prototype, the prototype design pattern in action. The newly created object assigned to the rainbow school variable will get functions from the school prototype and will assign values for properties at the time of object creation. The name property will contain the value rainbow school. This property will be writable, enumerable, and configurable. We'll also assign the num students property with a value of 600, which will be writable, enumerable, and configurable once again. I'm now going to go ahead and log out to the console this newly created rainbow school object, which we created using the prototype design pattern, and enroll Martha as a student at this school and conduct the science class. Save your files, switch over to Chrome and hit refresh. And let's take a look at this new school object that we constructed. You can see that the name is Rainbow School, num students is 600, And you can see in the proto object that we have the enroll student and conduct class methods. And the console messages also tell us that we've successfully invoked these methods on our Rainbow School object. We've enrolled Martha in Rainbow School and conducted the science class. While you're writing your programs in JavaScript, it's quite possible that you want to use the prototype design pattern in order to build objects using a prototype, but you don't want to use object.create. Here we are back in the prototype pattern.js file, and I'm going to now select all of the code that I've written here and get rid of this code, because we'll start afresh and see how we can build objects from a prototype, but we won't use object.create. The prototype that I plan to use to construct objects is called another school prototype, and I'm going to set this up in the form of a JavaScript object. Now, remember that JavaScript best practices state that you should have just function definitions in your prototype, and properties for the prototype should be a part of object creation, and that's exactly what we'll do now. I've defined a function here called init, which I'll use to initialize the properties for this object. The init function takes in two input arguments, the name of the school and number of students studying in the school, and I assign these values to this dot name and this dot num students. As soon as an object is created, we'll use this init function to initialize the properties of the object. Once again, I have the same functions on the prototype that I've used previously. Enroll student, which takes in one input argument, the student name, enrolls a student in this school, and conduct class, which takes in one input argument, that is the name of the class, conducts a class in that school. Instead of using the built-in object.create function in order to implement the prototype design pattern, I'm going to create my own function. I'm going to define my own custom function here called create school. This create school custom function is going to take in the name of the school and the number of students in that school. Within the create school outer function, I have an inner function named school. And this inner function school is what I'll use to construct school objects. We'll construct school objects, then initialize them using the prototype that we had set up earlier. Let's see how. The first thing I'm going to do is to assign the prototype property of the school function to another school prototype. So any object that we construct using the school function will have all of the methods defined in another school prototype. That is the init method, the enroll student, and the conduct class methods. Remember that in JavaScript, all functions are objects and all objects have the special prototype property. So school.prototype is equal to another school prototype. This is how we ensure that all of the methods in our prototype are available in our school objects that we construct. Once we've assigned the prototype property for school, we can now construct a new school object using the new keyword. And I'm going to assign this newly constructed school to the new school variable. Now that we have an object, let's initialize the name and number of students in that school. And we can do that by invoking the init method, newschool.init name num students, and then return this newly constructed object. In this way, all school objects created using this create school function will have another school prototype as its prototype object. We now have a function that implements the prototype pattern without using object.create. Let's now invoke that function. I'm now going to construct a new object using the create school function. The name of the school is Global School, and Global School has 400 students enrolled. Global School is the variable that holds this constructed object. I'm going to log this object to the console to examine its properties, and then after having saved my files, I'll head over to the browser, hit refresh, and take a look at the object that we just created. If you expand this object, you'll see that it has the property name and num students. This is thanks to the fact that as soon as we construct the school object, we invoke the init method, which assigns this dot name and this dot num students to the values that we had specified. All of the methods that we had specified in the object that served as the prototype to create this school object are present in the proto property. If you expand the proto property of the school object, you can see that we have conduct class, which takes in the class name, enroll student, which takes in the name of the student, and the new init method, used to initialize the properties of this object. You can expand this init method and take a look at additional details as well. Now, all that's left for us to do is to head back to our code editor and verify that we can indeed invoke methods on this newly constructed school object that come from the prototype. So global school.enroll student, I'm going to invoke twice with the student names Damien and Fabian. And I'm going to call global school.conduct class for English. I'll now head back to the Chrome browser and hit refresh on this page. And you can see that these functions were successfully invoked. Damien and Fabian have been enrolled in the global school and English has been conducted. In this video, we'll discuss yet another creational design pattern, the builder pattern. The builder pattern seeks a solution to the following problem: creating and assembling the parts of a complex object directly within a class constructor or within a function is inflexible. It commits the class to creating a particular representation of the complex object and makes it impossible to change the representation later. The single constructor solution to build objects essentially commits the object to a single representation, and the representation cannot be changed without changing the class or the function itself. The builder pattern seeks a way out of this. The builder pattern separates the construction of an object from how the object is actually represented. You have a separate construction process to construct the object in a step by step manner. And the same construction process can be used to create many different object representations. The builder design pattern provides a construction process that helps solve these problems. How can the same process be used to create different representations? And how can a complex object's construction process be simplified? The builder design pattern can also be set up to parse a complex representation of an object and then create different objects based on that representation. For example, you might define your object in the form of a serialized string, and this string is then parsed to create different objects based on the parameters in the string. A great example of how the builder pattern might be used in the real world is the step by step construction of a SQL query. Imagine that you have a builder class which is responsible for building up SQL queries. Now, SQL queries can be very simple. You might have just the select, from, and where clauses to select specified records from a table, or SQL queries can end up being arbitrarily complex. You might have nested queries, multiple filters that you might choose to apply on your data, the group by aggregation, the limit clause, and so on. If you have a programming language API that allows you to construct SQL queries, this SQL query builder allows you to build up your query in a step-by-step manner. At every step, you'll specify just one part of your SQL query. What fields do you want to read from your table? Which table do you want to access? What filters or conditions you want to apply on the records that you're reading in? All of these clauses are specified one at a time, and every step further builds up your query. So the query is a complex entity with many different parts, but you can construct the query in a step by step manner using the builder pattern. Now, applications that use your SQL query builder class might build the query exactly once, but once the query has been constructed, it might be run or executed multiple times in different contexts. And this is a situation where the use of the builder pattern fits perfectly. The builder pattern is great for step by step construction of a complex object. Specifically, if the complex object has many optional parameters which may or may not be specified. The builder pattern also separates object construction from its representation. Once the query has been built up, you'll convert it to a string format, which can then be run on a database using some kind of connection to that database. The builder pattern thus parses a complex construction process into simple constituent operations. Every operation is simple by itself, but together they make up a complex object. And there are explicit phases when you use the builder pattern for construction of an object and the usage of an object. Let's imagine how the builder pattern works by thinking of a real world situation. You have the client who is a customer, the cashier who is the director of the build process, and the restaurant crew, which is the actual builder of the meal. These are the typical set of entities involved in any restaurant. You have the customer who may go in and order the kids' meal, and placing the kids' meal order is typically done to the cashier. The meal might be built up step by step, adding in all of the individual ingredients. The final meal, though, is delivered by the restaurant crew directly to the customer. Now, the cashier and the restaurant crew work together in a step by step manner to build this meal up. The cashier might give directions to the restaurant crew. The first step might be to cook and prepare all of the food that goes into this kid's meal. The second step might be to put in all of the drinks that make up this meal. Now, based on whether the client ordered takeout or not, the third step might be to package the food and the drinks together in containers. And finally, you might perform additional steps to deliver this meal to the client. And what the client is looking for is the meal given to him at the very end. So, how do you decide whether the builder pattern is the right one to use in your situation? You should take a look at your code and what you need to implement and see whether you have objects that are highly configurable and complex. It may be possible to tweak your object with a large number of parameters, but many of these parameters may be optional, may not be specified up front. Many of these parameters may also come with sensible defaults. Given these two properties, it's quite possible that constructing an object with the right setup is quite complex. If you feel that is the case, you know you need the builder pattern. You don't want to overwhelm your clients with all of the optionalities and configurable parameters that are available in your object. This is where you'll use the builder pattern to provide a simple step by step process to construct your object. The builder pattern is actually extensively used in the jQuery library, which is very popular amongst JavaScript developers. The HTML structure of your page is just a hierarchy of DOM elements, and often you'd want to dynamically construct the elements that make up your page. Dynamically constructing the elements in your page is what allows you to build interactivity into your web pages. Now, every DOM element has to be constructed and styled individually. Each DOM element has many attributes and properties, and when you construct this element, you need to specify the right values for all of these properties so that the constructed element looks and behaves like you want it to when it's embedded within your web page. If you've used jQuery, you're probably familiar with the jQuery object that is usually referenced using the $sign. The $sign allows us to dynamically construct DOM nodes and specify the characteristics of the DOM element that you're building up in a step by step manner. Once your DOM element has been constructed, you can use a chain of method invocation, that is the builder, to specify the text contained within that DOM element. You can specify the text in the form of simple strings or complete markup. You can also specify partial markup. You can specify attributes such as the href attributes, any CSS classes that you want to apply on this element, any handlers that you want to wire up to this element, and so on. In this demo, we'll see how we can implement the builder design pattern in JavaScript. All the code for this demo we'll write within the folder builder pattern. Currently, we are working in the file builderpattern.html, and we'll write our JavaScript code in builderpattern.js. The basic idea behind the builder pattern is that you want to separate the construction of an object from how the object is actually represented. And the builder pattern is extremely useful to construct objects that are complex in nature. So instead of constructing the entire object in one go, you'll build up a complex object in a step by step manner using a separate builder object. The builder pattern is not very commonly used in JavaScript, but you'll find that JavaScript libraries such as jQuery use the builder extensively, and we'll see a jQuery example in just a bit. When you use the builder design pattern, the client or the user can build up complex objects without exactly knowing what's going on behind the scenes, what's involved in object construction. In this video, we'll see a more general purpose example of how the builder pattern can be implemented in JavaScript. Let's head over to builderpattern.js and start coding. The objects that we'll try and construct using the builder pattern are different kinds of vehicles. So you'll find that the code here is very familiar because much of this code we've seen before in earlier demos. Here is a class vehicle with a constructor that takes in a vehicle type and assigns to the this.vehicleType property. The vehicle then has a print details function which prints out the vehicle type, make, and model of the vehicle. We also have two other functions that make up the vehicle interface: the drive function, which simply prints out a console log statement, and the fill fuel function, which again prints out a console log statement. This vehicle class is the base class for a number of different types of vehicles that can be constructed. We have the class car, which extends the base vehicle class, and within the constructor, it invokes the superclass constructor and specifies the vehicle type as car. We have another class here, truck, which once again extends the base vehicle class, and within its constructor, it invokes the superclass constructor by specifying vehicle type equal to truck. We also have the class two-wheeler, which extends the base vehicle class, and it invokes the superclass constructor by specifying vehicle type two-wheeler. These are all the different types of vehicles that we can construct using our builder. So let's set up our builder, and we'll do this once again using an immediately invoked function. The object returned from our immediately invoked function here is assigned to the variable vehicle builder. Our immediately invoked function definition starts on line 43 with the open parenthesis. We then have the function body, and on line 50, we have the closing parenthesis indicating that the function definition is over. We immediately have an open close parenthesis indicating that this function is defined and immediately invoked. Immediately invoked functions allow us to create variables and methods that are hidden from the global scope. I have a variable called vehicle instance that I've assigned to null within my function definition, and I'm going to return an object and expose a few methods in that object. The objective of this builder is to allow us to construct different kinds of vehicles with a variety of different properties. So we don't have to set up the properties on our vehicles ourselves. We'll simply use the builder abstraction. The builder object stored in the vehicle builder variable has a create function which takes as an input argument the vehicle type. This is what will allow us to specify whether we want to construct a car, a truck, or a two-wheeler. Based on the vehicle type that the user has specified, the create function performs a switch operation to check for the vehicle type and then instantiate a new vehicle of that type. So if the vehicle type is car, we instantiate a new car and assign that to the vehicle instance. If the vehicle type is truck, we instantiate a new truck and assign that to the vehicle instance variable. And if the vehicle type is a two-wheeler, we instantiate a new two-wheeler object and assign that to vehicle instance. Observe the use of the vehicle instance object. The vehicle instance object holds a reference to the current vehicle being constructed using the builder. Thus, the vehicle instance holds a reference to the object currently being constructed by our vehicle builder. Notice the return statement at the end of this create function for our builder object. We return this. So we return a reference to the builder itself. We don't return the constructed object. Returning a reference to the builder is important because this is what allows us to chain function invocations on the builder object so that we have an intuitive API to construct our vehicle object using the builder. So it's common practice for every method of the builder to return a reference to this, that is, the builder itself. And you'll find that all but one of the builder methods will return this, that is a reference to the builder. Let's go on and take a look at the next function that the builder offers. This function on the builder is called make, and it allows us to set the make of the vehicle that we are building. Make takes in an input argument make and simply sets the make of the current vehicle instance to the value that we've passed in. And once again, at the very end, we return this, that is a reference to the builder itself. In addition to make, every vehicle also has a model. So the next method that we expose on our builder is the model function, which takes as an input argument the model value that we want to assign to our vehicle instance. We assign the model value and return this, a reference to the builder. Let's move on. The next method that the builder exposes allows us to specify the color we want for our vehicle. We pass our vehicle color in as an input argument, assign the color property for the vehicle instance, and return this a reference to the builder object so we can continue building our vehicle. The next method that the builder exposes is wheels, allowing us to specify the kind of wheels that our vehicle has. We assign the wheels property to our current vehicle instance and return this a reference to the builder. At this point, we have a number of methods on the vehicle builder allowing us to slowly construct our vehicle, that is our car, truck, or two-wheeler, specifying wheels, color, and so on. We are now ready to get our constructed object, and in order to get access to our constructed object, we'll invoke this build function on the builder. Now, within the build function, we can check to see if the required properties on our object have been set. Now, for any vehicle, I consider the make and the model of the vehicle to be required properties. So I'm going to check whether we have set values for the make and the model of the vehicle. And if we've not, I'm going to throw an error which says, please specify make and model of the vehicle. If our current vehicle instance that we are in the process of building has a value for make and model, I'm just going to go ahead and return the current vehicle instance. Build is the last method that you'll invoke on the builder to get access to the fully constructed object. Now that we have defined our builder, let's go ahead and use it. But before that, let's take a look at the vehicle builder object on the console log. Let's switch over to our Chrome browser and click through to the builder pattern.html file. We'll open up Chrome Developer Tools, and here on the console we have the vehicle builder object. We had returned this vehicle builder object from our immediately invoked function, and all of the methods that we had defined on the vehicle builder are available here. We start off by creating a new vehicle instance, then we can call any of the other builder functions in any order. And finally, when we have finished constructing our vehicle object, we'll invoke the build function that will return to us a reference to the constructed object. Let's expand each of these methods in turn and take a look at what's within it. It's enough for us to explore just one of these functions here because all of the other functions will be very similar. You can see that the build function takes in no input arguments, and if you expand the scopes, you can see that it has access to two scopes, the global scope and all of the constructors and classes within the current script, builderpattern.js. Now that we have the builder set up, it's time for us to use the builder. We've already seen what the vehicle builder object looks like. Let's go ahead and create a very simple vehicle. I'm going to use vehicle builder.create to create a new instance of the car object, and then I'm going to invoke the .build function. First, let's focus on what exactly happens behind the scenes when we invoke the create function on our vehicle builder. We pass in the vehicle type, which happens to be car, which means based on the switch statement that we have within the create function, a new car object will be instantiated and assigned to the vehicle instance variable. Remember, the vehicle instance variable holds the current object that's been constructed. When we invoke the create and build functions on our vehicle builder, observe how we chain the method invocations. We call vehicle builder.create.build. This chaining works because the create function returns this. It returns an instance of the builder, and once we have a reference to the instance of the builder, we can then invoke the .build function on it. This chaining is possible because the create function returns this. Once our vehicle instance has been created, using the create function, we immediately invoke the build function on our vehicle builder. What do you think the build function will do? Here is the code if you remember. We'll check to see whether the make and the model of the vehicle instance has been set. Has it been set? Not really. We've only constructed the vehicle object, that is a car, but we haven't set its make and model. So this bit of code is going to throw an error, and we can confirm this by switching over to Chrome and checking. When we hit refresh here, you can see the error here within the console messages. The error says, please specify make and model of the vehicle. This is an error that we have thrown. So let's go ahead and fix this vehicle builder to specify the make and the model. First, I'll only specify the make. Once again, I use the vehicle builder with chained invocations because this makes it very easy for us to see what properties are being assigned to our vehicle instance. I'll create a car object and set its make to be Honda, then invoke the build function to get access to our newly constructed car object. We've only specified the make but not the model. So if you switch over to Chrome and hit refresh, you'll find that an error will be thrown once again. The error will say, please specify make and model. We haven't specified the model. We need to fix that. I'm going to go back to my builder here, and in addition to assigning the make of the car, I'm going to specify the model as well. The model is Civic, the make is Honda. That's something we had specified before. Now I'm ready to build this car. The car that we are going to build will have the make as well as the model. I'm fairly confident that this time around my construction of the car object will be successful. So I'm going to print out the car object within the console logs. Let's go back to Chrome and hit refresh, and this time there is no error. The car has been successfully constructed using the builder. If you expand the car object, you'll see that all the properties that we specified have been set correctly. The make is Honda, model Civic, and the vehicle type is a car. If you expand the proto for this object, you can see that it was constructed using the class car, which is exactly what we wanted. And if you further expand the nested proto property that you see here, you'll see all of the methods available on our car object: drive, fill fuel, and print details. Now that we know how to use the builder to construct objects, let's add in some additional properties to our car by invoking additional methods in this chain of invocations. I'm going to specify wheels for my car. I want my car to have alloy wheels. Note how we can include additional method invocations to set properties for our car one by one. We are building up our car object in a stepwise manner using our builder. Switch back to Chrome and hit refresh, and here is our updated car object. We have the make, model, vehicle type, and we've also specified that our car has alloy wheels. Back to the code editor to continue constructing our car. In addition to alloy wheels, I want my car to be red in color. This is an additional customization that I want. Switch back to the browser, hit refresh, and expand the car object, and you can see it now has the color property set to red. Back to our code here. Now that we know how to build a car, let's go ahead and use the vehicle builder to create a truck. The first method invocation in the vehicle builder should always be the create function because that's what constructs a new vehicle instance based on the vehicle type that you've passed in. The input argument that you've specified for the vehicle type in the create function is equal to truck, which means a new truck will be constructed by our builder. This newly constructed truck will be assigned to vehicle instance, and that is the object that we modify when we invoke the other functions on the builder. We'll set the make to Ashok Leyland, model to C204, and we'll have this truck have forged wheels. And finally, we'll invoke the build function to get a reference to the truck that we constructed. If you want to confirm that your newly constructed truck has all of the right properties, let's print it out to the console log. Switch over and hit refresh on your browser. And here is our truck. Vehicle type is truck, make Ashok Leyland, model C204, and it has forged wheels. The builder pattern seems to be working very well so far. Let's round off by using our vehicle builder to construct a motorbike. We'll call the .create function by specifying two-wheeler as the vehicle type. The make is Bajaj. The model of this motorbike is Zoom. The color is black. And finally, the .build function will return a reference to the motorbike that we just constructed. I'm going to go ahead and print out to the console this bike object. We'll switch over to Chrome, hit refresh, and confirm that our bike object has been constructed with all of the properties that we have specified. And yes, indeed, it has. In this demo, we'll see an example of how the builder pattern is implemented in a real-world framework. And the framework that we'll work with is the Jquery Framework. Is free and open source and widely popular with web developers. That's because jQuery is a one-stop shop for many things. You can perform DOM manipulation, DOM traversal, animation, AJAX requests, everything using jQuery. If you've used jQuery before, you've actually used the builder design pattern without even realizing it. The idea of selecting specific elements and manipulating them is all based on the builder, as we shall see in just a bit. Now, in order to work with jQuery, we need a reference to the jQuery library. So head over to jquery.com/download in order to download the latest jQuery library from the site. At the time of this recording, the latest version available is jQuery 3.4.1, and that is the version that we'll work with. But even if you're using a later version of jQuery, things should work because what we are working with is a very fundamental part of jQuery. Now we'll work with the jQuery development library, which has JavaScript in the uncompressed form. Click through and let's take a look at the file that we are about to reference. You can reference this file directly on the jQuery content delivery network, or even easier, I'm simply going to copy all of the file contents here. I've selected all of them, hit Control C and copy over the file contents of this JavaScript file to your clipboard. Switch over to where you're going to write your code. I'm within a folder called Jquery Builder Pattern, and I have a file named jquery 3.4.1.js. This is the file where I'm going to paste in the code from the jQuery library. You can see that this is the file that I have referenced within my HTML file. There is a script tag with source equal to jQuery 3.4.1.js here. Just a few other details to note in this JavaScript file. We have a CSS style defined. The class name is stylish paragraph. And within the body of this JavaScript file, I have a div with ID equal to root. That is going to be the root div of whatever HTML I add to this page. Switch over to the file jquery 3.4.1.js and paste in the contents that we just copied. We now have the jQuery library on our local machine, and we'll see how the builder pattern is implemented in jQuery. Switch over to jQuery builder pattern.js. We are now ready to start writing code using the jQuery framework and using the builder pattern in jQuery. Now, if you worked with jQuery before, you know that all of our jQuery code is typically wrapped in this document ready handler. If you've never used jQuery before, I'll give you a quick primer as to what's going on here. The dollar sign you see is a shortcut reference to the jQuery framework. The dollar is simply a reference to jQuery, and it's just like invoking the jQuery object. Dollar followed by parenthesis is the selector that we use in jQuery to select the DOM nodes that we are interested in our HTML page to perform certain actions on those DOM nodes. You'll find this general pattern, dollar followed by parenthesis, over and over again when you use jQuery. Dollar and in parenthesis document selects the document that corresponds to our web page. This little bit of code that you see here wires up an event handler to the document ready event. Whenever the document ready event is fired, that's when the code within this event handler will run. Wrapping all of our jQuery code within this document ready event handler ensures that the DOM of the web page is always ready and can be accessed and manipulated in our code. The code within this function will execute only when the DOM is ready. I'm now going to use the builder pattern in jQuery to construct a new paragraph element that I'll append to the HTML structure of my page and display within my web page. Dollar followed by the p tag will construct a new paragraph element. This is the portion of the jQuery builder that creates a new HTML element. And once the element has been created, I'm now going to have chained method invocations that will add additional properties to this element. The dot text function will set the text content of this HTML element to be hello world. This simple builder here builds up the HTML element and assigns the text content. And then finally, when we have the paragraph along with its text content, we append this paragraph element to the div with ID equal to root. Observe how we use chained method invocations, which is typically a hallmark of the builder. I'm now going to switch over to the Chrome browser now and click through to jQuery builder pattern.html to take a look at the DOM that I've constructed using the builder pattern. You can see that hello world is displayed here on screen, and within Chrome developer tools, You can see how the HTML structure of this page has been constructed using the Jquery Builder. Expand the div with id equal to root, and within that div, you'll find a phtml tag, that is a paragraph tag with the text content hello world. Any builder generally offers a number of different functions that you can use to build up the object step by step, and the Jquery Builder is no different. Here, I'm going to construct a paragraph element, and instead of setting the text content of this paragraph, I'm going to set some HTML within this paragraph. I'm now creating a new paragraph element as specified by the dollar and the p tag. The second one, I invoke the .html function on it to set the nested HTML within this paragraph. The nested HTML contains the same text hello world but within bold tags and italic tags, and I append this new paragraph element to the div with id root. Back to the Chrome browser, hit refresh, and here are our two paragraph tags, both saying hello world, but the second one is in bold and is italicized. If you expand the div element, you'll see the nested paragraph tags within it. Let's expand the second paragraph tag. You can see the nested bold tag and the nested italic tag, and then the hello world content. The builder that jQuery offers goes beyond just specifying the text and HTML content of an HTML tag. You can even specify attributes that you want to assign to your HTML tag. Here I've specified that my first paragraph should have ID equal to paragraph ID. This is another step that we have taken towards constructing the final form of our paragraph element. Let's switch to Chrome and hit refresh, and you can take a look at the first paragraph element here, expand it, and you'll see it now has ID set to paragraph dash ID. Back to our code, the same attribute function can be used to specify multiple attributes for our HTML tag. ID equal to paragraph ID, I'm also going to specify a style attribute. I want the color of this paragraph to be equal to red. In addition to specifying CSS style, using the attribute of an HTML tag, jQuery builders also give you access to a CSS function. You can invoke the .css function to apply specific styles to the elements that you construct. I'm going to use the CSS function here to apply a specific background color to my hello world paragraph. Background color is set to yellow. Having made these two changes, we are ready to hit refresh on Chrome browser, and here we have it. Our hello world is now displayed in the red color and has a yellow background. And if you expand the HTML structure of this page, you'll see that our first paragraph has all of the styles and attributes that we assigned it. The style attribute has color set to red, background color to yellow. So the CSS property that we used has modified the style attribute as well. The jQuery builder also allows you to assign CSS class names to style the elements that you construct. Here I've used the add class method invocation to add the stylish paragraph CSS class to my paragraph element. This CSS class here increases the font size of our paragraph and adds a little padding. So let's switch over to Chrome browser and see the effects of this change. Hit refresh, and here is our paragraph with an increased font size and additional padding. If you expand the root object, you can see that the class specified for our paragraph element is stylish paragraph. Back to code to continue building up our paragraph element. I'm going to set the width to be a fixed width equal to 250 pixels. The width can be specified as a part of the style attribute as well, but there is a special width function that the builder offers. Let's switch over and hit refresh, and let's take a look at our paragraph with a fixed width equal to 250 pixels. Let's go back to our code and add in a height for our paragraph as well equal to 200 pixels using the height method. Now the paragraph that we've constructed here has not just a fixed width but also a fixed height. We are step by step building up the paragraph that we want. Now back to our code for one last enhancement to our paragraph object using the builder pattern that jQuery has to offer. I'm going to invoke the .click function that allows me to add in a click event handler for my paragraph. The input to this click method is a function object that takes as its input argument the event. And within this function, I'll simply display a JavaScript alert indicating that you clicked on this paragraph. We've now set up this paragraph to be exactly how we want it to be, complete with an event handler. Let's switch over to Chrome and hit refresh. And once you've refreshed this object, you can click on this object to see the execution of the event handler. And there you see it, the JavaScript alert saying you've clicked on this paragraph. In this course, we continued our exploration of common creational patterns in JavaScript, specifically the singleton pattern for single object instantiation, the prototype pattern for cloning, and the builder pattern to construct complex objects. In addition, we also covered the implementation details of these patterns, as well as the features and best practices to be kept in mind while building out those implementations. At this point, you possess the knowledge needed to correctly understand and implement this singleton pattern for situations where exactly one single instance of a class is required. Utilize the prototype pattern with and without the use of object.create, and use the builder pattern to construct complex objects, both in native JavaScript and using the popular jQuery library. You are now set up to explore structural design patterns in detail, such as the module and revealing module pattern, the facade decorator, and mix in design patterns.